Morning guys, today we are back with another problem, and today's problem statement is based on prime number sequence and it's based on array list. And this problem we are going to find some unique pairs of array lists which sum up to a particular value. So I'm just quickly gonna give you some examples. So first, this problem is based on prime numbers, okay. And secondly, this problem has a template given in array list, so we need to be comfortable using list operations. Okay, so today's problem statement is based on prime and it is based on list operations. So for example, we will be given a number, say for example n, and we have to find that particular number results to in what format. Okay, so say for example we are given a number as 7, right? So let's check the example of the question and then we can analyze it. So if we check the problem, so it is saying that we will given a number n equals to 10 and then we have to check the possibilities. Okay, so say for example when we are given a number n equals to 10, so what we can write it over here as n equals to 10. Now this 10 can be divided into what two prime factors which add up to become 10. So you can see 3 plus 7 or 5 plus 5 is equals to 10. We are going to take only those prime numbers where the first value is lesser than the second value. Since 3 or first value of I, say for example first value of j, then we are going to return 3,7 as answers. Now suppose if a question comes like this, that n equals to say an unknown value, which does not return a prime number, where no prime addition possible, then what we are going to do, we are going to just simply return -1 and -1. Okay, so this is our objective. So how we are going to do this? So we are going to solve this using a technique over here. Okay, so first I'm going to come. So first, basically what today we are doing is we are doing array list operations and is prime algorithm. So first we are doing an is prime algorithm. We have to declare a class A solution. We have to check whether that particular solution is an is prime or not. Then we have to do basic operations in array list. Okay, so this is our function boolean is prime. We are taking a number n. Now we are returning if n less than equals to 1, we have to automatically return false, that there cannot be primes possible. If n, so boolean is prime checks whether the number is prime or not. Okay, so if n less than equals to 3, we are returning true. If n modulus 2 equals to 0, okay, n modulus 2 equals to 0, or n modulus 3 equals to 0, then we are returning false. If, say for example, since we have already iterated from 0 to 3, now it's remaining, we are starting with 5. So if 5 and I square, okay, is basically square of the num lesser than equals to num, and then we are iterating it with a positive of 6 counters. Now we are checking the prime condition. If number modulus of I equals to 0 or number modulus of I plus 2 equals to 0, then we are returning false, else we are returning true. Lastly, we are using an array list of integer type to get the primes. We are starting the loop from 2 and we are going to L by 2 in order to increase the efficiency over here. And then we are checking if the is prime and is prime is true for I and n minus I elements. So we are storing it in a array list of say type integer. We are storing it in an array list of type integer. Name of the array list is result equals to new array list. Okay, equals to new array list. So then we are doing operations of adding into the list. We are adding result dot add I n minus I. Okay, if this works, it works, then we are returning result. Or else we are going to create a new array list of type integer, and which is having a result equals to say new array list. So over here also we are returning -1, -1, -1. So that's how we are returning those values. Okay, so that's how we are solving this today's problem statement. Now we are going to the coding part. So if you see the coding part, first we are defining a class solution, then we are checking a boolean is prime method, then we are checking whether the number to whom we have to break down into two parts is lesser than equals to 1, then false, or else if it is less than equals to 3, then also it's false. So 3 cannot be break down into two parts which has prime contributions like that. So like that. So 3 can be break down into two parts, 2 and 1. Okay, if it is 0 and 1, yeah, it will work. So what you can see is if n modulus of 2 equals to 0 and n modulus 3 is equals to 0, then what you can say is we are returning it as true, okay, or else we are returning it as false. So similarly, we are checking from the fifth element to the square of it is to the last element. And lastly, we are doing the public static array list where we are storing the resultant over here. So this was all about today's problem statement. I hope you could understood it. Let's submit. So we have successfully completed today's problem statement, and I'm looking forward to solve more problems. Thank you.